All right, so we're talking about polynomials. Today's kind of an introduction to what a polynomial is. You've been working with them for a while, but you probably haven't had an official name or definition to it. So the first part of this video, I'm going to spend the next couple of minutes talking about all of these different terms up here. I would pause the video, and I want you to read through each of those boxes and then hit play when you're done, because I'm not going to read them word for word. I want you to read the definition, and then I'm going to explain them over here with this example on the left. So go ahead, hit pause, read each of these boxes up here at the top. There's 1, 2, 3, 4, 5, 6, 7 boxes that I want you to read. All right, now that you're back, first box talks about terms. Now, terms is a group of numbers and variables being multiplied together, but they're separated by pluses and minuses. So in this example over here on the left, the 23x cubed times y, all three of those are getting multiplied. The 23 is getting multiplied by the x cubed, which is getting multiplied by the y. Together, those make a term. The negative x is getting multiplied by the y. Those together make a second term. The 58 is getting multiplied by a y. That makes a third term. And then this minus 4 is the fourth term. So this example has 4 different terms. They're separated by a plus and a minus. Okay. Now, you've been dealing with combining like terms for 2, 3, 4 years now. Remember, the reason they're separated by pluses and minuses is because you can't put them together. If all of these were just x's, if this was 23x minus 1x plus 58x's minus 4x's, I could just add them all together because they all have an x after the number in the front. But in this case, they don't have the same variables, and that's why we don't add them together. They have to have the exact same variable in order to combine them together. This first one has an x cubed and a y. The second one has an x and a y, but it's not an x cubed, so we can't add those together. So remember those rules. What other definitions do we have on here? Variables, one you should be well comfortable with at this point, right? It's the letter part of the term. So the x cubed y is the variables there. The xy, technically there's a 1 in front. We don't see it, but there is a 1 right here, which is called the coefficient. That number in front of the variables, that 1's the coefficient, the xy is the variables. 58 is the coefficient, y is the variable. Negative 4 is what we call a constant because it doesn't have a variable attached to it. It's just negative 4. What am I missing here? We've got degree of a term. So if you take your variables, like in this first term right here, 23x cubed y, we don't see it, but the y has a exponent of 1. We don't write it because that's a waste of time. But the degree of this term is what I get if I add the exponents together that are connected to the variables. So that 3 right here and this 1 get added together. So this term has degree 4. The x and the y term, each of those only has an exponent of 1. So this term has a degree 2. The y over here has 1 exponent, and it's just the number 1. So this one only has a degree of 1. This one at the end has no exponents with no variables with exponent. So this has a degree of 0. All right. Now, the polynomial overall also has a degree. So each of these individual terms has a degree, but we also say that the entire polynomial has a degree, and that degree is based on the largest term's degree. So in this case, this first term had a degree of 4. So that's what we would say the polynomial has. We would call this a 4th degree polynomial because the largest degree in that polynomial is 4. If I had like 2x squared minus 4xy squared, this would have a degree 3 polynomial because this x and this y squared make a degree 3 term. The first term only has degree 2. So this would be a third degree polynomial. Okay, last thing before we start doing some actual math. Standard form. All standard form means is that you write the numbers and the terms in a certain order. We like to start with whatever has the largest degree and then work our way down to end with a constant. So the example above is already in standard form. You can't combine anything together, and we have the biggest degree 4 starting and then a degree 2, degree 1, degree 0 term. Let's do an example. Well, actually, we've got examples right here underneath. So negative 4y plus y squared plus 3. This first term, right, I've got negative 4y, I've got y squared, I've got plus 3. The negative 4y has degree 1. The y squared has degree 2. The 3 has degree 0. So I put them in the order from biggest to smallest degree. So instead of the y squared being in the middle, the y squared is going to go to the front. And then I'm going to put the minus 4y second and then the plus 3 at the end. Notice that I took the sign that was in front of the term with it. So the negative went with the 4, the plus went with the y squared. This second example, I've got 15x minus x cubed plus 7. This one has degree 1, this one has degree 3, this one has degree 0. So if I put them in order from largest to smallest, I go negative x cubed plus 15x plus 7. That would be standard form. The next one, it's pretty easy to see that the last one's the biggest, so I'm going to put that in front. I don't care that it has a negative number in the front. I care which has the biggest exponent. And then I'm going to put the plus 5m to the fourth plus 2m next. Okay? And then the last one, you've got a degree 0 constant right here and then a degree 1 coming after it. So the negative y would go first, the plus 1 would go second. So remember, constants have degree 0, so they go last. All right, couple of rules to just sum up all of this stuff. For a polynomial to be a polynomial, these rules have to be followed. You cannot divide by a variable. So you can't have something like 3x squared over y to the fourth. That y to the fourth on the bottom, you can't divide by a variable, so that's not a polynomial. No negative or fractional exponents. So that means I can't have 3x to the 1/2. That's not allowed. I can't have 3x to the negative 2. That's also not allowed. No roots or operations. So I'm reading this one now. No roots or operations other than add, subtract, multiply. So you can't have 3x to the fourth square root y. You can't have any roots in the problem. You can't have any operations that aren't add, subtract, multiply. So you can't have, and I know those are most of the operations you guys use, right? But you can't have factorial. That doesn't work. That makes it not a polynomial. And then the last one, you can't have an infinite number of terms. So a polynomial has a number of terms in it. It can't go on forever. I can't have 3x plus 2x squared plus 7x cubed plus 8x to the fourth and so on forever. It has to stop at some point, okay? All right, let's do a little bit of math now. Polynomials can combine together. You've been doing this. It's called combining like terms. We even practiced it in this class. In this problem, I have a polynomial, 3x squared plus x minus 4. I have a second polynomial, 2x squared plus 2x minus 3. I want to add those two polynomials together. So I do what I've always done. I combine things together that have like terms, right? That have the same variables. Because this is a plus in the middle, none of these, and there's no multiplications in front of the parentheses, none of these parentheses matter. Really, all I have is 3x squared plus x minus 4 plus 2x squared plus 2x minus 3. So I'm looking for what can go together. I always start with the biggest exponent. So when I see this x squared, I'm looking for anything else that has an x with a 2, like this first one, 3x squared. Those are the only x squareds. I'm going to combine those together. 3x squared plus 2x squared is 5x squared. Okay. Then I'm looking at I'm going to drop down to regular x's. So there's a plus x, there's a plus 2x. Those can add together and become plus 3x. And then last, I look at constants. I look at numbers that don't have an exponent. So this -4, this -3, those go together and become -7. So my simplified expression is just 5x squared plus 3x minus 7. Nothing else can add together because they're not like terms. So the next example over to the right wants you to find the sum of this exponent, 5x minus 1, and x squared minus 5x. Sum means add them together. So I just do 5x minus 1, that polynomial, plus x squared minus 5x. Now, I don't need the parentheses, but I like to write them so that you can see the two separate polynomials in the beginning. Really, I just have 5x minus 1 plus x squared minus 5x. Okay, so what goes together? I've got an x squared. I'm going to start there, but it's the only one I've got. So that's what I'm going to write down first, x squared. Now I'm going to look for just regular x's. There's one right there. There's one right there. 5x's minus 5x's leaves me with 0 x's. There is no reason to write 0 x's. We don't do that. And that leaves me with -1. It's the only constant. It's all by itself, so I just get x squared minus 1. So this simplifies to become x squared minus 1 would be my final simplified expression. Now, if we have a minus in the middle here, that changes the problem pretty dramatically, right? So if I want to do the same thing, but instead of adding polynomials together, if I want to subtract them, I can't just ignore these parentheses because of this minus in the middle. If you remember back in, I think you probably learned this for the first time in 7th grade, this negative has to get distributed to everything that comes in the parenthesis after it. The parenthesis in the front doesn't matter. This -4m squared is the same. This plus 3m is the same. This minus 1 is the same. But that negative gets multiplied by m, and instead of a positive m, that makes it a negative m. And then that negative gets multiplied by 2, which makes that -2. Now I look for what can combine together. Again, I'm going to start with squares, so -4m squared. And then I'm going to move on to my regular m's. So I've got 3 m's right here, minus 1m. You don't see the 1 in front, but it's there. We've got one of them. So 3 minus 1 is 2 m's. And then last, I've got a -1 here and a -2 here. So those combine to become -3. So my final simplified expression is going to be -4m squared plus 2m minus 3. That's an m right there. Okay? Same thing on this next example. It wants you to subtract the 2. Why don't you pause the video? I want you to try this problem on your own and then hit play. I'll go through it quickly and we'll see if you got it right. Okay, so I am starting with -3c squared plus c plus 5, and I'm going to subtract the polynomial 8c squared minus 4c plus 1. I'm really careful that when I write this the first time, I put my polynomials in parentheses because I'm taking this polynomial. Oops, I wrote that backwards. I'm subtracting this. Let me color these for you. I didn't read it very closely. I'm subtracting -3c squared plus c plus 5. I'm subtracting that from 8c squared minus 4c plus 1. So I need to switch these around and put the 8c squared in front, minus 4c plus 1, and I'm going to subtract negative 3c squared plus c plus 5. We should probably read our math a little bit slower, right? So this negative gets distributed to everything that comes after it, all of those terms. So 8c squared is the same, minus 4c is the same, plus 1 is the same. This negative becomes positive 3c squared. The negative c, this negative getting distributed to the positive c gives me negative c, and the negative going to the positive 5 gives me negative 5. And now let's look for what goes together. C squareds, that's 11c squared. I add those together. Negative 4c minus 1 more c becomes negative 5c, and then plus 1 minus 5 becomes minus 4. There's my simplified expression. Okay, couple story problems. Write a polynomial in standard form that represents the perimeter of the figure. So I'm over here on the left. Perimeter means I add up all the sides. So I've got this blue side, I've got this yellow side, I've got the red side, I've got the green side. I need to add those sides together. So I'm going to write down, let's start with the blue, 3x. I'm going to add 2x plus 1, the green. I'm going to also add the red at the bottom, the 3x, and then I'm going to add the yellow, which is also 2x plus 1. I don't really need the parentheses because everything's getting added. So 3x plus 2x plus 1 plus 3x plus 2x plus 1. I'm looking for what goes together. 3x's, 2x's, 3x's, 2x's. All of those just have one x connected to them, so I can add those up and I get 10x. And then I've got a plus 1 and another plus 1. Those add together to become plus 2. And it's in standard form because I start with the biggest exponent, which is just x to the 1, and I end with a constant. Okay, last problem. This one's a little bit hard to see. I'm glad that we decided to put this on as an example because once you see it, it's not as hard as it looks. But it says you drop a ball from a height of 98 feet. So you're up here on this building, you drop this ball, and your friend is down at the bottom, and he throws a ball up. So your friend's ball is going up, your ball is going down. The question says to write a polynomial in standard form that represents the distance between your ball and your friend's ball. Now, what I need you to remember is that the distance between two things, the way that you find the distance between two things is by subtracting them from each other. In math, that's how you find distance. You subtract one from the other. So I'm going to take the height of the ball. I don't know what it is. I just have a formula for it. And I'm going to subtract the height of this ball. And that should give me the distance between them because that's how I find distance. So I'm going to write down negative 16t squared plus 98, and I'm going to subtract the other polynomial, negative 16t squared plus 46t plus 6. Now, I got to be careful. I've got this negative in the middle that needs to get distributed to everything that comes after it. Hopefully you start to see a pattern because all that really does, this negative right here, all it does is change this to a positive, this to a negative, this to a negative. So it just changes the sign of everything in the parentheses. So I got negative 16t squared plus 98 plus 16t squared minus 46t minus 6. Let's put things together. Negative 16t squared plus 16t squared. Those cancel out. I have no t squareds. So I need regular t's. Negative 46t is right there. So negative 46t. Constants. So plus 98 minus 6. So that would be plus 92. And right here's where you panic because you don't have a number. You don't have a number right now. All you have is an expression. Well, you can't find a number because you don't know what time that we care about. We don't know if we're talking about 5 seconds, 10 seconds. But what we do know is whatever time I pick, I could plug that time into this expression and I would know how far apart these two balls are. So at time 2, I would know that this is negative 92 plus 92, which means the balls are 0 distance apart. So at 2 seconds, these balls are the exact same height. All right, your turn. You've got a couple problems. There's 5 on the left that you need to add together. I know I didn't give you space to do it after each line, but you've got space to add them together down below. I gave you 5 more problems that you need to subtract polynomials. Again, I didn't give you work to do it after each problem, but I gave you space to do it down at the bottom. Then you have a story problem similar to the one that we just did. And another story problem similar to the one that we just did. But at the end of the last one, it asks you to write down some information based on the definitions you learned at the beginning of the video. So don't skip number 17. You'll use your answer from number 16 to do number 17. Come see me if you have any questions or problems, and good luck.